this is my Lab 1 Physics 2 Lab 1 report. The purpose of this lab was to discover the amount of charge on tape and the electrons on the tape. The fundamental principles and equations that we use, Coulomb's law, saying that F equals Q1 times Q2 over R squared. We also use the force of gravity equals mg, and we use the fact that oppositely charged objects will attract each other, and similarly charged objects will repel from each other. We also used Newton's third law in this experiment, saying that every action has equal and opposite reaction, and all these principles are used in the experiment that I will explain. The main results were that the charge was able to create a force larger than gravity on a different piece of positively charged tape. I'll explain how this was true, and I hope that it will be clear by the end of the lab. Explanation. The experiment. The system was the bottom piece of tape, or the top piece of tape, and the surrounding is the other piece of tape that is exerting a force on it, as well as gravity, which is also exerting a force on the tape. The initial conditions were that initially both pieces of tape were neutral, but once we ripped them off of another piece of tape, both pieces of tape became charged with an unknown charge from an unknown amount of excess electrons. This is crucial to the experiment because once they were held together, we could see that they would start to react and push away from each other. Then we would take these two charged pieces of tape and set them up. We'd put one acting like a bridge between two books, and we'd put the other piece of tape on top of it, and they would exhibit some type of force in which they would move apart from each other, which was clear that there is some type of force acting on these objects that is greater than gravity. It's able to counteract the force of gravity that is forcing both of these tapes down. The coding. Here's a little screenshot of the code that we used for this experiment. The main part of this code is just that the net force on a piece of tape is the force from gravity and the force from the other piece of tape that is exerting a charge on it. Those two principles were used, and they showed that the distance between these two tapes is 0.035 meters. We could use a lot of this was used as a calculation of sorts, calculator, to determine a lot about tape, how far they were from each other, how large the charge was, and eventually how many electrons were on the tape. So using this and calculations from data, we found that there was around that the charge on one piece of tape was calculated to be 1.633 e to the -8 coulombs, and that there was around 1.5 e to the 23rd electrons on the tape. This was used knowing the charge of an electron divided by the surface area of the tape, and it was very useful to figure this out and to find out about how. It's a rough estimate, but it was good. So we had a lot of potential errors that could be causing this data to not be super accurate. One, we assumed that each piece of tape has a even layer of electrons across it, which is not entirely accurate. We also ignored air resistance on a moving object and treated the long tape as though it was one point charge at the center, which is not entirely accurate, but it made it a lot more simple to do the equation. We also assumed that each U-tape had the same charge, which is also not accurate, but also made it much more simple to calculate the charge, the charge on that piece of tape. Here are the results of the experiment. This is the simulation that we made in the code, and you can see that the object has force of gravity exerting on it and a repellent force from the bottom piece of tape that is repelling this other piece of tape, making it go up a little bit until the force of gravity equals the force from this charge. Overall, you can see that the charge on each piece of tape is calculated to be what I said before, and you can find the deficient electrons through this calculation. So what if electrons had a positive charge and protons had a negative charge? Well, nothing would really change, as both would counteract each other, and the fact that oppositely charged objects attract and similarly charged objects repel would stay the exact same. It's also important to know to handle the charged tapes as little as possible, because when we are handling the charged tapes, we are taking away some of those extra electrons, which would make it less charged and would skew the experiment data. So yeah, that answers the questions. And thank you so much for watching the video. I hope you learned something new. I hope I answered everything on the rubric. Thank you.